Is this audible, sir?
Yes, madam, I can hear you. Yeah.
A warm welcome to one and all present here. First, I would like to welcome our department student, Ms. A. Archana Devi, 3rd BSc Computer Science, to deliver a welcome address.
A very blessed morning to all. It gives me great joy to welcome our Honorable Principal Ma'am, our esteemed guest speaker, faculty member, and all participants. Thank you all for joining this significant FTF session on AI-driven industry. Thank you.
Thank you, sister. Next, I would like to welcome Mrs. D. Ruth Ma'am, Assistant Professor of Computer Science, to introduce the Chief Guest Address.
Good morning to everyone. With a career spanning over 25 years in IT sector, Rajesh Kumar Raja sir currently serves as Director of APO India Private Limited, where he oversees India operations. His professional background includes sustainable consulting expertise within the fintech industry. Beyond his corporate and educational conferences, roles as a committee member of the A.K.D.Dharma group. Mr. Raja demonstrates a commitment to community wellness. He volunteers with the mental health organizations, Atma offering lay counseling services, and personally embodies well-being as a yoga and nature enthusiast. Thank you.
Thank you, ma'am. Now, I would like to welcome our Chief Guest, Mr. Rajesh Kumar Raja sir, Consultant Technical Manager, Arabic Financial Services, Software Limited, Bangalore, to share your valuable words.
Thank you, madam. Thanks a lot. Good morning, everyone. First of all, thanks a lot for the college secretary, your college correspondent, secretary, the principal madam, and the head of the Department of Computer Science, and all the staff, and the participating staff here, the students. Thanks again for this opportunity, for giving this FTP program to the A.K.D. India company. So this is the first FTP that we are doing in the college, and we are so happy to do this. Yesterday, our founder, our chief technology officer, Krishna Kumar sir, delivered about the latest trends in the AI. So today, in this AI industry, we speak a lot about AI. Yeah, before that, I'll just give you a minute and share my screen. Are you able to see my screen, madam? Can someone come?
Yes, sir.
Okay. Thank you. Yeah. So today's topic will be the foundational AI technologies and architectures. So we've been talking a lot about AI. So when we get up, the news is all about AI. So what AI did today, how many things happened today, what new things came out, and what are the job losses because of AI. So it's been very challenging times. So meaning how we can upskill the AI, how we can try to understand and how we can make the best use of AI in our daily lives as well as in our career as well. So this has been the forefront in the current scenario. So everyone has been compelled or they've been compelled to know about the AI, what exactly is there behind AI, what exactly it does, and how it is impacting our daily lives, our daily use cases across any field that we take, educational field or any manufacturing or retail, any field that we take. So there is a profound impact of AI. And we are going to see today what is that is behind AI, some fundamental concepts, meaning what exactly the AI is all about, how the data is trained, models, and all of the stuff, and also we'll see some of what are the future holds on for the AI. So the topics will be So the topics will be mainly the introduction to AI, then we'll just dive into machine learning, what is machine learning, the core engine of artificial intelligence is machine learning. And the next comes the deep learning, how exactly the deep learning is being utilized, what are all the algorithmic improvements that are happening currently. And then the next one is, what is the backbone of all these things actually, like artificial intelligence, machine. We all talk about it, but the backbone of all these things that we talk about today is the neural networks. So what is this neural network is all about? How is this significant in the whole AI space? And we are going to talk about PA architectures, their practical applications, and what are all the future trends. And finally, we have a Q&A session. So that is the plan we have today. So to start with, so what is intelligence? So if we consider, if we say, what am I intelligent? What is that intelligence that we're talking about? So when we say this guy is an intelligent guy, what exactly do we mean that? So intelligence by Webster dictionary, it says that it is the capacity to learn, it is the capacity to reason and understand, and similar forms of mental activity. So that is called as intelligence. So when the faculty is teaching a concept in the class, so how much a student is able to learn, how much a student is able to reason out of it, what exactly the teacher is teaching, the reasoning part of it, and then the understanding part of it is what we call as intelligence. And the aptitude in grasping the truths behind the concept that we deliver, and the relationship between how are we interconnecting between the one concept and another concept that we talk about. So how are we building the relationships, the network between the two concepts, and what are the facts and meanings. So these are all cumulatively referred as intelligence. So reasoning, when we say reasoning, it is all about the processing the conclusions and creating a judgment out of it, and the inferences, whatever that we see, whatever that we infer, whatever that we from the fact, is all about reasoning. And understanding is nothing but the ability to get the meaning of the concept and how you judge that, what exactly it means to know and how to comprehend it. You have a context of how the context is set, and what are all the environment based on which that the fact is being presented, and what is that you have understood about it. That is what understanding is all about. So together we call all these as intelligence. So this is the fundamental core before even we talk about artificial intelligence. So here the other forms of intelligence is self-awareness, emotional knowledge, and how do we plan, how do we create the creative work we do, how do we understand, which is an extension of what the understanding part of it. So these are all the forms of intelligence that we talk about today in today's world. So now we're going to just getting into what is artificial intelligence, right? So artificial intelligence is a field in the computer science that focuses primarily on machines or software that can perform what a human can do. So we all know about what a human intelligence is all about, which we talk now, like reasoning, understanding, but how a machine can mimic the same thing, how a machine can get the data, process or understand, reason the data, and how it can identify the patterns, and how it can infer and give the results. So that is what is all about the artificial intelligence that we are talking about. So the core abilities of AI today is the learning part of it, which is improving the performance by using the data, the reasoning part of it, which is making the decisions or solving the problems logically, and the perception, how we interpret the data that we get. Like it can be of text, or it can be of a sound, or an image, or anything else. So how do we see each of these data through our sensory inputs? And the language understanding, how are we understanding the way it is getting presented? It can be a reading, or you read about it and understand it, or you write about it and understand it, or I'm responding in human language. So, conversations, that's how you understand any concept. And once you do all these things, then taking action out of it, interacting with the environment based on the information you have. So that is the ability of AI. So here, which is robots, as an example, we can say, so at what environment, what is it needs to do? We have multiple robots today. So based on all the core abilities, it will take action and then it just perform the way it is supposed to do it. So examples of AI you see on an everyday basis today, multiple things you have. If you get an email, the email can, some emails go to your inbox, some emails go to your spam filter. So it is all about how it is getting the data, the emails are getting categorized and put across. And voice assistants, you have Alexa, you have Hey Alexa, or Hey Siri, or OK Google. So these are all the extension of AI, how it's being implemented in today's gadgets. And image recognition in the phones for security systems. So you have cameras being highly modernized. So you try to identify who the person is, and based on the image, based on the facial attributes, you understand the facial ID is there, and so that's how the image recognition is being used in AI. And recommendation systems. So anywhere in social media you get into, so whatever that you see, so the background you will understand, okay, this is the liking that you have on this particular content. So if you're going to like a particular movie or a particular person's music, so the next content will be something similar to it. That's how you get pulled into social media. And, so the proliferation of social media just because of this recommendation systems, and similar to so which is extension in your Netflix or Amazon or YouTube or Spotify. And chatbots. So chatbots have become now it has become it has replaced many of the customer service agents. We constantly interact with chatbots. Either to seek data or also to seek any service in the banking or financial services. You see, there will be a lot of chatbots from any website that you open, the banking, they'll be asking, okay, tell me what is this, how can I help you? So that way, they're trying to automate this thing, and the chatbots will understand what your query is and see how they can offer the person's level. And then if it goes complex, then a particular customer service agent will come and help you out. And the self-driving cars. So this is again, there's been a lot of work going on, and currently it has just come to road in the US and the Europe areas where you have Waymo, you have Uber cars, which are self-driving cars in the US and in Europe as well, some parts of Europe as well. And we talked about the spam filters of the email. So these are all the examples that we touch upon in our daily life, how AI is impacting you or how AI is helping you in a positive way, sometimes negative. Yeah, so we talked about this. So the science and engineering of making intelligent machines. So we know how humans will think about, how humans will understand the data, how humans will process the data, and then based on the processed data, they will just try to deliver the data. So we are trying to mimic the same thing in the machines. So the goal of is to enable machines mimic and potentially exceed human cognitive functions. So when you say human cognitive functions, how complex a brain can be, we don't know. So the brain is the most powerful organ in the world. So you have billions of neurons and billions of connectors, and you can, and based on the inputs or based on the sensory inputs, based on the cues you get, it will try to react and respond. And we are trying to build something similar to it. But there is a far, we are still yet to go there, but the goal is there. That's what people say about. So the science and engineering of making intelligent machines, especially intelligent computer programs, is what AI is all about. And John McCarthy, he's been considered as the father of AI, and so that's what his words are all about. And in simple words, making computers think, act intelligently like humans, but using data on algorithms. So these are all the things that we feed into the machines, and we tell them how to act and behave in that specific context. So the first birth of AI was something like this. There's a guy called Alan Turing. He's the one who came up with I propose to consider the question, can machines think? That was the first question which came, and which was the seed for all these proliferation of AI today that we see here. So it was in the 1950s, 75 years back. You can see how much it has evolved from this particular simple question that was thought about. So during his experiments in his career or academic career, that's what I understand. Alan Turing is a good. And just to touch upon the key milestones, this 50s is when this guy, Alan Turing, he just talked about the Turing test, where all this started. And then there was some conference happened where the next level of John McCarthy conference, that's where the artificial intelligence came. And there was a chatbot which was created in 66, and there was a robot in 69, and there was some 1974-80, there was some AI funding which was ongoing for at the university level. And then there's an expert system, it started picking up, wherein the rule-based decision making was happening. And then in 97, there was an IBM Deep Blue computer which defeated Gary Kasparov. They had multiple, that's when the neural networks and neurons were highly talked about. And then the Apple introduced Siri in 2011. And where you have an NLP, you can talk to a mobile phone, give commands, and it was there to you, help you. And then the deep learning was held in AlexNet, where the ImageNet is the highest database of images that you have today. And then the Google's DeepMind, this AlphaGo, that's the one which made a big impact in 2016. And then, and then the ChatGPT started in 2022. So from then on, there is no stopping. So it was continuous, just a roller coaster ride for AI. So people started GPT, everyone started using it, and the huge boom actually. Every year there was a huge boom, and today we talk about Gemini, Claude, you name it, ChatGPT, Copilot, Grok, all those models that we have today, and Llama 3, Meta's Llama 3. So they're all going to the next level of AI computation. And you have an agentic AI, where you have building agents based on the inference that the AI gives, and then you have protocols which are defined based on the communication between these agents, like agent-to-agent protocol or MCP, which is model context protocol. So these are all the protocols which have been come up today, so that the communication between the AI agents is becoming standardized. So getting into the topic aspect, so AI is a very high superset of term that we are talking about. So as of now we talked about it's an ability of a machine to imitate intelligent human behavior. Whatever a human does, we want to imitate that in the machine. So that is what we call it as artificial intelligence. So when you go a little deeper to the next level, which is called machine learning. So how you achieve this, how you interpret this machine learning as, so it's an application of AI that allows the system to learn what is being fed into. So you're feeding the data, and based on the data that you feed, the learning happens, and then based on the learning, it will try to understand the context, the reasoning happens, and then it gets an experience, and then the output comes out. So this is the machine learning part of it. So here we'll be seeing that supervised learning, unsupervised learning, reinforcement, all this stuff. And then comes your deep learning part, which is even more concise, and we're going a little deep into it, where you have complex algorithms which are used in the machine learning process to understand the deep neural networks to train the model. So there are multiple ways how the model has to be trained, so that what data is coming in and how to interpret the data, and then based on the data, what exactly what reasoning has to be done, reasoning or understanding has to be done, based on which the applications can use these interpretations in the reasoning of the model that we have pre-trained. So this is all about the high-level AI, ML, and deep learning part of it. Suddenly, as we saw in the key milestones, the last 4 or 5 years have been huge movements, humongous movements, I say. So why all this happened all of a sudden, and why sometimes it's scary, sometimes it is interesting. Again, it depends upon perception, how we take it and how we walk through it. So the reason for these boom primarily getting attributed to these factors. So the first one is the big data, the availability of. So how all this happened is the availability of the massive data sets. Big data was huge in 20s and early 2020. So you have a huge Apache Hadoop data, big data was happening, wherein the data was you were able to analyze, you were able to understand the data from multiple forms. Initially, the data was primarily stored in the file structures, then it was stored in the database, DBMS structural databases. The moment when the social media started proliferating, there's a lot of unstructured data. So when a lot of unstructured data, when we say it's all about the Facebook or Instagram or YouTube content, which cannot be stored in structured data. Those are all unstructured data. And these became your input data. So when multiple YouTube channels or multiple Facebook accounts, billions of accounts or billions of Instagram accounts, when they started coming, the data became huge. And how do you, and Google, Meta, they need to make money based on the behavior each and every user does. So they were trying to process these data actually. So that's when the data started coming. At the same time, the hardware resources were becoming very cheap actually. So that also attributed to this huge proliferation of data. And when the data was there, the processing and the hardware processing was more in hand, and the developments and the advancements in that was happening so quickly. So that's how the computational power, the GPUs, the TPUs, and NPUs started coming up. So Google started, even before Google, so the NVIDIA is a company which was primarily into gaming. So they were primarily trying to do the parallel computation when the games were online, the games were streaming online, and they were using the matrices and trying to see how they can give a real-time feel for all those games. So that's when their chipsets and their processors were so powerful to give a real-time experience. So when the data started coming in, the big data started coming in, they wanted to use their existing hardware to see how they can process this data, and that's when the whole artificial intelligence started booming. NVIDIA, where they're the number one today in the processing power, and so that's where the GPUs, graphical processing units, they just mentioned about their processors, and today their Blackwell processors are the number one in the world, meaning how much petabytes of data they can process in milli or micro or nanosecond level. I'm not sure exactly the metrics, but that's how powerful they are. And when NVIDIA was started doing it, Google also started they came up with the tensor processing units and neural processing units, and every chipset vendor they started coming up with the computational power to process all these big data. Apparently, the algorithmic advances also were happening. Whatever were there at research level in the universities, they started building their deep learning techniques and machine learning techniques to the next level pretty frequently. And so these algorithmic breakthroughs were main factor, is one of the factors for this boom. And the next is the big data availability that we talked about, primarily resulting due to the social media that started for the past 10 years or 10 years, I believe. And then the increased computing power. The processing power has been it's so exponential, and when it started becoming so exponential, and the data was also there to feed in. So the combination of the computing power and the data is all resulted in this today's AI magic, I would say. So, and when these started coming up, there was a significant investment from all the big companies because they had huge money in them, and they wanted to invest and see how these are giving results so that they can benefit their product line. And the growing demand to increase the productivity of the industry's level, and so when people started building products out of it, then there was a growing demand and see what is the next and what next. So that's how the AI started coming up. And there was also a positive feedback too. I mean, there was no negativity around, except that what data feeds in is what it comes out. So there is a kind of skepticism there, but still there is always a positive feedback which has given factor for this AI today. So this one is the types of AI. So today, as we talk about, we are all in the artificial narrow intelligence. So where is the artificial intelligence can be only at a specific task level, like Siri or Alexa or OK. These are all there. So self-learning cars mostly are there at the UI. But when you go to the general artificial intelligence, AGI, so it is somewhere equivalent to human level intelligence across multiple tasks. So it is still hypothetical because we are just trying to mimic the brain structure, but we have not taken into account the physical activities that we do today. Actually. So today I can lift anything from the ground if something falls down. But that's where the robots are coming up. But there is a huge gap there. The physical AI which needs to grow, and a lot of companies are working towards it. Or physical AI to be somewhere. We are not sure that actually they can be equal to the human intelligence. And the super AI is something even more higher level. It exceeds the human intelligence that we talk about. But these are all still at a very hypothetical stage. We are at the paper level, but we are not sure if that has actually happened. If that happens, then it will be I don't know if it's the same to the mankind or the world. Yeah. So now we'll just go into the core components of the AI system. What exactly the components are about, the algorithm, the data is the main thing, and then the algorithms part of it, and then the output, final output part of it. So we saw this example when an email comes to you in your inbox, so it gets classified based on the classification algorithm. It gets marked as a spam or not spam, so it goes to inbox or it is spam folder. So that's the algorithm that we talk about. So the data can be in multiple formats. It can be a textual data, it can be of structural data, it can be of speech data, it can be of signals as well, 3D signals or analog digital signals, and it can also be of images and videos. So all these are different sources from where all these input data are coming from. So we are using all this structured data and unstructured data for us to train, to understand, to reason what this data is all about. So the training happens with all these data, and then that's when a foundational model is built. So this foundational model is the core part of the AI based on for its reasoning and understanding purposes. It will understand the context, it will understand and keep it within itself. And based on the foundation model, the application layer, the output layer, where the tasks they get benefited out of this data that is processed and trained. So you have you have the information extraction, like any data that you can extract. Today is foundation models, some of the large language models. Today is GPT or Claude, Sonnet, and the multiple LLM models are there today. And the applications that they get benefit are object recognition, the image categorization, sentiment analysis. When a sentence is written, what is the sentiment of the sentence actually? What is the sentiment of the text message that we have? And the question and answer. So these are all some basic examples how the applications, the end applications are getting benefited out of this trained data which is stored as a foundation model. So these are all the basic foundation technologies that which are fundamental to artificial intelligence, which we can touch upon. You must be aware of these, but we just go through each one, what exactly it is and how these each of these are helping the AI ecosystem. So machine learning to start with. So we talked about what machine learning is, a subset of AI, the process where the systems are learning the patterns from the data to make decisions without any agents programming. So there are multiple learning approaches like supervised learning, unsupervised learning, and reinforced learning. So these are all multiple ways of the data getting trained and based on which the output is given. And then we have your deep learning. Again, as we know, the subset of machine learning which involves the neural networks. So neural networks with many layers in it and capable of modeling complex patterns. So pattern recognition is one of the key attribute or key characteristic, I would say. So when patterns are identified, then it will try to respond based on the pattern that is stored. So these complex patterns are based on high dimensional data, multiple dimensions data based on which the patterns are built upon. So they are used in image recognition, they are used in speech processing and much more other applications. And the third, primarily most important one, other applications, natural language processing. So techniques for machines to understand and generate human language. So enabling applications like chatbots, language translation. So today Google Translate is one of the main things where we identify so many languages and try to translate in the language that they want. So it happens in the real time as well, and that way you can translate to, if you travel to any country, you go to Japan, so online translation happens and it helps you to communicate in a real time way to the other person without any language barriers. Computer vision. So this particular area has come out in a very long way, where the technology is enabling machines to interpret visual data. So you have cameras everywhere, primarily for the security reasons. So you have home security, you have industrial security. So there are multiple applications for computer vision, and once the computer vision helps to get the visual data, it will try to understand what type of object it is, which is object detection, and try to make inference out of it. So the applications are huge, and a few applications are like object detection, like number plate detection, or medical imaging in the hospital medical area. If you try to get the images and see what exactly, based on the patterns, it will try to identify what kind of issue the person is having. So that's outcome of medical imaging. Speech recognition and generation. So systems that convert whatever the language that we speak, automatically it will convert into text. Speech to text, you have multiple systems today, so that you can just dictate and the text comes below. And even the vice versa also happens. So when you write a text, so there's multiple voice avatars you have. So based on different language styles, linguistic styles, you can just make multiple videos today based on the text that you do. It gives you the output very close to the native people that they belong to. So these virtual assistants and accessibility tools are primarily powered by these AI systems. And then the generative AI, so which we are using it left, right, and center. Like we ask any questions today, send any kind of a texting, or any kind of emails, or any kind of messaging that we do. So we just go to the ChatGPT and ask how to do it, what to do it, and that's one of that's the best friend you have today for any person who is using the computer. And these are all mainly based on the foundation models that we talked about. So which is GPT, Dharma, and stable diffusion. So these are the few foundation models from different companies like Meta, OpenAI, and stable diffusion from sure. And finally, the expert systems, it's quite old. The rule-based programs designed to emulate human decision-making in specific fields. So this started quite old actually, but still it is evolved and it is being used in few of the applications as well. So how this machine learning, how the whole thing happens is you're collecting the data. When you're collecting the data, 7 stages of machine learning is what we have showing you here. So the one is the data collection, where we talked about the multiple sources like text, images, videos. You have signals. You have multiple things. You have so you get the sources. See how good the quality of the data is. Actually, most of the data, if there is a human interference, there will be a lot of error. It's error prone. And then we need to have a data quality check to make sure the input data is really qualified. So that's when the reasoning and the understanding part of it will be more accurate, closer to the human level. Otherwise, the output it's going to give us, it can be false, that can be not that we expected. So quality of the data ensure that's one of the main thing. And then the preparing the data. So when we talk about the quality, we are going to clean the data, what is that we needed for our application, and transform the data. So there could be multiple null values or values which are totally not there, which has to be defaulted to a particular value so that it makes good sense when you come up with the analysis of the data analysis part of it. So the next one is model selection. So where once your data is collected and the data is prepared, then you need to select the model specific to your application and what algorithm that you're going to use so that the model is built based on that, and then you start training the model actually. So you label the data, and then once you have a trained data set and a test data set, using the training data set, you will just start training the model. And based on the algorithm that you would like to have. Then the model evaluation. So once your model is trained, then you will evaluate the model, and then the model improvement happens by fine-tuning the model. So it cannot go right at the first phase. So it has to be continuously trained, it has to be continuously tested, see the output, and then see how close it is to the desired output, and then we need to go back and then train again, and then come evaluate, do the fine-tuning of the model, and finally when you deploy and see the inference, and that's when you can say that okay, this is 80% close to the actual output, or 90% close to the actual output. So the tuning happens until that level, only then it can be given to the public so that it makes it's useful to the outside world. So we talked about the foundations, like a foundational model we talked about, and neural networks also talked about. So these are all the basic foundations of the modern AI. So the core computational structure behind this deep learning is neural networks that we talked about. And when you say neural networks, so there's different kinds of convolutional neural networks. They are primarily for images, primarily for processing the images. And recurrent neural networks primarily for the sequential data, time series data that they need to process. It's more effective. And the latest one is the transformers for language and multimodal tasks. So these are all the neural network advancements that has happened over the time and helping the whole AI process. So the large neural networks, which are the foundation models, when we talk about here, is the large neural networks which are pre-trained on massive data sets to provide a flexible starting point for a variety of AI tasks. As we talked about the different applications like different generative AI or speech recognition or image recognition. So these foundational AI technologies, they enable the systems to perform like language translation. We spoke about understanding the documents, image synthesis, autonomous driving, and much more applications today we have, which will also be touched upon later. So neural networks, when we talk about, as I mentioned, you have different like convolution neural networks, recurrent neural networks, and transformers. Transformers are the latest one. So they are there for specific types of data. Actually. So these are all these power the foundation models, how it's being built, and help the AI capabilities. So generally, a neuron structure in your brain is something like this, where you have axon, you have dendrons, you have nuclei, and you have how the neuron in your brain. There are billions and billions of neurons, by the way, and the data that comes to you through your sensory inputs is getting there are neurotransmitters which will transmit the data to the multiple layers where it is supposed to go. So that is how our brain is structured. And if you see the right side part of it, so these are all the neurons, these are all the signals which come to the neurons either as an input or output actually. So through our sensory systems is what we have today in our human body. So we wanted to mimic the whole thing, this powerful structure in the neural networks. That is the idea behind this neural network. And so these are the inputs and what exactly is the output based on the information that it has come in. So this is at the human level, or the biological neurons that we talk about, and these are the artificial neurons that we talk about. So you have inputs in multiple forms like structured data, unstructured data, images, signals, and all those stuff. It gets processed based on a function, weighted function, or an activation function, or a linear function that we talk about. And then once this processing, based on this processing, you get the desired output. So these are all the artificial neurons, how it gets the data, how it processes the data, and gives the output data. Yeah, this is another picture which talks about the input layer, the hidden layer. This is where the processing that happens, like a functional which is getting a function which is introduced, or the weights which are introduced to the input data. Once this weights are introduced based on the algorithms, then the output data is getting comes out. So this gets complex to a very higher. This is a very basic level. So you can understand there are billions of parameters or trillions of parameters today. What ChatGPT 5.1 claims about with multiple parameters when it's training a model. So you have so many data at the input layer level, and even more complex at the hidden layer level, and then you get the output layer. So these are the differences of the meaning, like you have CNN, RNN, convolution neural networks, like recurrent and long short-term memory networks, then the transformer, which is the latest one. So the use case is different for each. So CNN is image processing, RNN is for time series data or sequential data. LSTM is primarily, they have a memory part of it where you can store the data at the memory level, and then the transformer is the natural language processing where the parallel processing happens, and it helps you in the parallelized data processing. And so there are multiple, like how it's getting processed, like spatial hierarchy is one of the, how the images are getting processed. So RNN and LSTM are at the sequential level, and transformers at the parallelized level. And how scalable it is. So transformer is highly scalable because of its parallel nature, and CNN also because of the image process, it quickly processes the images. Because of the sequential nature of the data, the scalability is low. So yeah, so this is how the different architecture they are, and these are getting applied for different use cases. So we talked about what foundational model is. It's all about massive, generalized, unlabeled data sets, and they can perform a wide range of disparate tasks like NLP, question answering, and image classification with highest level of accuracy. And this is based on the training of the model that we talked about, based on the input prompts. So we have, unlike traditional ML models, there are also general purpose foundational models and specific purpose, even for the specific purpose they build models. But these are all pre-trained and it is ready to use, but otherwise the model is going to take some time. So these general purpose foundational models can be used as a base model for developing more specialized applications. So how many parameters? It differs from every based on the compute power each company has. So BERT has around 340 million parameters in 2018, whereas GPT-4 had 170. Today, I don't know, it is more than 300 trillion in 2025. It should have doubled for sure, or tripled for that matter. So the computational power has been going every month actually. Every month they are releasing a version, and the number of parameters used for building these models is going high. And mainly it is helping for automating the tasks, it is helping for pattern recognition, it is helping for the reasoning capabilities, which is being used in the end applications. The end applications, when I talk about, it is the language translation, image classification, customer support, healthcare, autonomous vehicles, and robotics. Yeah, this we talked about. So the final applications is what here we are like visual comprehension, and speech to text, text to speech, all those stuff. The same thing, I think we saw the same image in the previous slide. So that the data can be of multiple ways, like text, image, speech, structured data, training, the foundation model happens, and the adaptation of the foundation models is for multiple applications, like question answering, sentiment analysis, object recognition, etc. So this is the actual pipeline. I think we also touched upon while training the data, like data sources can be multiple sensors, text, images, user data, and then the cleansing of the data, labeling and augmenting the data. And then training the model using the algorithms that we have, that we need based on the ML and DL techniques. And then the model repository, where you have a versioning of the model, each version can cater to a different need. And then you're storing them, and you're using them based on the application that you're planning to do. That's when machine learning operation comes in, which is ML. So when you're deploying it, it can be exposed by a REST API or an SDK, or even at the API, you can deploy it, and then the application can use it at these levels. So monitoring also becomes quite trivial, meaning how much drift you need to drift, what is the output, how much it is drifted out beyond the desired output. You need to detect that, and you need to retrain that if required. And so that's when the retraining triggers happen based on the threshold output. So these are all the different layers, like first one is the data layer from the bottom-up approach, then the processing layer, then the model layer, then comes the hardware layer, which provides the compute power of the AI, then finally is the application layer. So this is again a pictorial mind map structure, where you have the data layer. When you talk about the data layer, comes from databases like SQL, NoSQL. It comes from data lakes like Hadoop and Spark, and data pipelines like Kafka and Airflow. So these are all the data layer, and then comes the pre-processing of this data layer actually. So like data pre-processing happens through cleansing of the data or transforming the data through an ETL. Can be an Informatica or any other open source ETL thing or Oracle. And then your training frameworks, you have multiple training frameworks like scikit-learn, TensorFlow, and PyTorch. And then the distributed training, where you do a Spark machine learning libraries, and other tools that you have for this pre-training, the training layer. Once this data is getting trained, then you go to the model layer where you have the traditional models, decision trees, and you have the deep learning structures that you have like CNNs, RNNs, and transformers that we talked about, and then the generative models like the GANs and the diffusion models, which are based on your specific needs. These models are getting trained. So once these models are getting trained, again, using the hardware and the infrastructure layer that we have. So the CPUs that is required for the data sets, as we talked about, the data sets can be massive. So there's a number of GPUs, CPUs that you need to put across, and the TPUs or NPUs based on the environment that you are working with, and then the edge devices. So it's not only the models that are getting deployed at the cloud level or at the on-prem level. Edge AI is one thing which is becoming more need of the hour today, and A.K.D.Dharma is the leader in the Edge AI model deployment of solutions are primarily on Edge AI. We yesterday Krishna talked about the products that we have and the industries that we serve based on the products which are primarily at the device level, edge level deployment and inferencing that happens at the device level or the edge level. We are also going to the even more the next level after the edge, which is the device level AI PC. So at the PC level, we are trying to like XR, VR devices or mobile access. So even at that level, we are trying to see deploy our models and see how we can detect an anomaly and inference and action over that. So that is the areas which are moving forward, and A.K.D.Dharma is doing a lot of our companies doing a lot of work on that, and we are getting a good traction from the top players in the like Qualcomm, Intel, and Oracle. These are all the companies that we work with, where we are working on these latest AI technologies. And then the application layers, where the applications are getting used, the APIs, the web apps, and the mobile apps, and the edge deployment that I talked about now. So these are all how the data from the beginning to the end, how it is input happens, how the processing happens, how the training happens using the infrastructure and how the application layer happens. So this is the complete system architecture of the AI, which is at visually shown as a mind map level. So key design considerations is scalability, how scalable it is, how latency. That's where the Edge AI is a winner of that. So the latency need not go to processing, need not go to the cloud level and come back. It happens at the edge level, and then the output is given to the application where it's kind of a real-time output. And then the ethics, how the data is, the privacy of the data, the transparency of the data, and how secure it is actually, by how it can protect, how the data is protected from the outside attacks, like any kind of attack that comes from outside, and how this machine learning operations are getting integrated actually, because of the continuous monitoring, whether it is the overfitting or overdrifting, and then retraining if it's required, then the continuous MLOps integration is very much required. So there are a few key challenges which I'd like to touch upon quickly. The data challenges. The data, if the quality of data is not good, then the output can also be not good actually. So the data plays a huge part of it, and if the data is really biased, then the output. So we cannot, whatever the output comes from the AI, we cannot always say it is 100% factual, because it all depends upon the input data. So, and it has to be audited to see how good it is, how unbiased it is. So those are all the challenges that we have today. And then the model challenges. If it's an overfitting, the test data can be really good, but when it comes to the training data can be really good, but when it comes to the testing data and the new scenarios comes in, it will perform very poorly. You don't know how to take the actual data. So there are some model challenges which we need to look at it, and training infrastructure as well. So not every model we can afford for GPUs, and so when the model size, when the parameters become less, then the accuracy of the model, we need to see how accurate it is. So that is again a challenge, and the energy consumption as well. And the security aspect which I talked about, like adversarial attacks or data poisoning, which is intentionally the data is fed to give false data. So that also happens these days, wherein there is no regulation to see what is the right and wrong data today. And ethical issues, this is again how transparent the data is, how accountable that we can just show this data as the right output. So these are all the ethical issues we have today, and there are few of the countries or few of the democracies, they've started working on it, but we are not sure how far they have gone through. And finally, is life cycle and machine learning operations, where the concept of drifting, monitoring, and continuous retraining has to happen for accuracy of the data, but it is questionable when it comes to the level of inferencing that we do to the desired outcome. And practical applications today in the healthcare, if you see, there's a lot of diagnostics and discovery that's happening. The education is trying to replace the tutor, meaning it's trying to help tutors in multiple ways. We need to see how best it can become your friend, and you can get that help from them. Finance, it helps in fraud detection. In the retail and e-commerce, it will help you in personalized recommendations. The manufacturing, this is playing a huge role in the industrial IoT, where yesterday one of the main presentations Krishna was talking about the basic camera feeds and the sensors, drones. We do a lot of in the oil and gas industries. We are working mainly and heavily based on predictive maintenance and actionable inferences. And so these are all the work that we do at the trio here in this space. And transportation, self-driving cars is one of the applications, and communication is real-time translation. That's happening today, and agriculture, where the precisions and a lot of agriculture work is also AI-powered. Drones are helping to monitor the crops and take actions when required. And the entertainment industry, the content creation and personalization, how much it is. So these are all multiple applications that AI is powering today. And tomorrow you have a very good talk. AI in the healthcare industry, and the upcoming talks will be on the meaning entertainment and with our fellow colleagues the next 2 to 3 days in the FDB sessions that we have. And the future of AI is generative AI is be everywhere, meaning we are looking at the larger scale, and AI at the edge that we talked about, and AI at the device that we talked about. And how responsible and explainable AI is. This is based on the transparency and the ethical aspects of AI. And quantum computing, AI, we are using quantum computing to accelerate the training of the data. So this is at the very nascent stage. Google is working on it heavily. And autonomous AI driving cars. And AI in scientific research, a lot of protein, lot of DNA level synthesis, cell level cell biology. So these are all getting traction in science and research fields. And human to AI collaboration, how much human to AI as a co-pilot, how they can collaborate is also to help their creativity and productivity, which is taking a lot of traction and a lot of applications that are coming. And finally, the regulation. So unless there is no regulation, then it can be used in any way which cannot reach where the safety becomes questionable. So that's where multiple countries are working on the AI Act, AI bills for rights. So these are all things which are coming up. Currently, work in progress, and it can gain more traction in the coming days. Well, yeah, that's it we have for the day, and I hope you took some takeaways from this session. I'm open to have any questions.
Sir, I have one doubt.
Yes, please.
So, what skills should the student focus on to start learning AI?
Oh, that's a good question. Good question. So, see, primarily, as we spoke today, I think you need to have your foundation strong. So, only when your foundation is strong, then you can start working on small projects, so that you gain confidence. How basically, I think if you want to get into AI, just learn the Python basics, so that you know there are multiple frameworks you have today, and you can use those frameworks. You have the code ready. You also need not write code. All you need to know is to understand what code is written today, so that you can see the output of what exactly you want. So even just to understand, you need to learn Python, and once you have the basics strong, and once you have the basic concepts, then you can start. You can just get enrolled into one of the courses. And and then you can just connect with people and ask more questions. That way people are always here to help you, and to move forward your AI journey.
Thank you, sir.
Thank you. Any questions in the chat? You can also put your questions in the chat if needed. All right, I think if we don't have any questions, we'll just end the session.
Yeah, okay. Thank you, sir. I would like to welcome Ms. J. Arundeepa, second BSc Computer Science, to deliver a vote of thanks.
On behalf of the Department of Computer Science, I extend my heartfelt thank you to your guest speakers, Principal Ma'am, factually, and all participants. We are grateful for your valuable time and contribution to today's program. Thank you everyone for your support.
Yeah, we have one question I'll just add before we end. So I think Shivashakti Madam had asked a question. What is the difference between the testing data and the training data? See, when the model is being built, you will be using the training data set, wherein you will get the data from different sources, and you will train the model. And once the model is trained, you will be testing based on how the model is, how the output is coming based on your trained data set. Ideally, the testing data set should be equal to the real world data. And then if it is somewhere different, even if it's different, it needs to understand what kind of data it is, and then it needs to give an output. So that's what the difference between the testing and the training data set. All right, thank you everyone.
Thank you, sir. Thank you, everyone.